Alright students, here we are. We're going to go over the homework problems for page 556. Looking at problem 1. A balloon is rubbed against denim and gains a charge of -8 microcoulombs. This symbol here is a Greek letter mu. Mu stands for micro, and micro is the prefix that we use for times 10 to the -6th. Just like kilo is times 10 to the +3rd, and milli is times 10 to the -3rd. So anytime you see micro, you need to use times 10 to the -6th. So back to our balloon and denim here. If the balloon rubs against the jeans and becomes negatively charged with, say, this charge, that means it stole 8 microcoulombs from the jeans, leaving the jeans at a +8 microcoulombs. And they want to know what is the electric force between them at this distance. So let's start setting it up here. Our equation, if you'll remember, is Coulomb's constant times charge 1 times charge 2 and divided by the distance squared. Now, notice from the problem, it says 5 centimeters. We will always use meters in our calculations. We will not use centimeters in calculations. We will not use kilometers in calculations. We will not use micrometers, nanometers, picometers, millimeters, centimeters, none of that. We will use plain old meters in all of our calculations. So you convert this over 0.05 meters, and then we throw in our squared. And if you'll please excuse my very low-tech calculator that I will calculate on the screen, and you can see how I did it. If I go 8.99 exponent to the 9th times, put a parenthesis in here for me, 8 exponent to the -6th, close my parenthesis. I have to be very careful on this calculator here, times parenthesis again 8, and then I put my negative in, exponent to the -6th, close my parenthesis, and hit equals. And then I'm going to divide by, I'm going to put my parenthesis again, just like I would encourage you to use a parenthesis right here. 0.05, I'm going to hit my squared, close my parenthesis, and hit equals. And if I'm not mistaken, I don't have the teacher's manual here at home, but if I'm not mistaken, 230 is the proper answer. So you should come up with negative 230 newtons. If you can't see that very well, that's what it says. About 230 newtons. If you're worried about significant figures, I'm looking at roughly 2 or 3 sig figs, so 230 newtons should be about what you get. Now, if you got 230 and then your exponents are off because you didn't do this here, or you didn't do this here, if you didn't adjust your powers of 10, but you still got, 2.3 times 10 to the whatever, you were doing the calculations properly. You just didn't know what to do with your exponents. And that's something we can fix over time. That's a very common mistake. Please remember that when you're putting this in your calculator, you want to put the parenthesis around the distance and the squared. That'll allow this only to be squared. I'm telling you, I tried to harp on it yesterday, but this squared right there is probably the #1 issue. Please don't let it become an issue. If there are questions in the room, you could pause and see if one of your classmates can maybe help you see what you did wrong, look at your calculator, and help you out there. You can pause the recording, and I'll give you a couple seconds to do that before I move on to number 2. Alright, moving on to number 2 then. Page 2 here. Let's take a look at this one. Alright, looking at number 2 here, we have a situation where we have 2 identical conducting spheres. Perhaps they are steel. Two identical conducting spheres are placed at the center of, where their centers are 0.03 meters apart. So there's our distance. One is given a charge of positive 12 times 10 to the -9th. I know that is improper scientific notation. Don't stress about it there. And the other is given a charge of negative 18 times 10 to the negative 9th coulombs. By the way, negative 9th is nanocoulombs, just in case we're talking about interesting units. Part A, find the electric force. Let's do that first. So if we grab our equation here, let's set this up again. Electric force is equal to, let me stretch that out. Again, Coulomb's constant times charge 1 times charge 2 divided by our distance squared. Let me get out my ultra cool calculator here. Try again. Clear. 8.99 to the 9th times parenthesis 12 to the negative 9th, close the parenthesis, right? Hit button. Close my parenthesis, times another parenthesis, 18, hit my negative because that's how this works, exponent to the negative 9th again, close that parenthesis, hit enter, and then I'm going to divide by parenthesis 0.3, square it, close the parenthesis, enter. Now that answer seems very, very small to me. I have to contemplate if it seems right. Well, that could be about right. Again, if you guys have drastically different answers, I got very concerned about halfway through that calculation. If you have drastically different answers, just give me a moment. I'm going to pause the recording and recalculate and just double check my work. Alright, I just double checked it, and yeah, I'm pretty sure it's the same answer that was on the screen previously. So it'd be 2.2 times 10 to the negative 2, 3, 4, 5. Looks like to me 2.2 times 10 to the negative 5th. Now, like I said, I don't have the teacher's manual in front of me. I would not mind if you guys look at the teacher's manual. It doesn't bother me one bit to double check my work even. Okay. So that's part A of number 2. Now let's talk about part B for number 2. In part B, the spheres are connected with a conducting wire. That I have right here. Conducting wire. And equilibrium is then achieved. Now let's think about that. If we have a negative 18 charge and a positive 12 charge, what's going to happen is 12 of these are going to move over and neutralize with these 12. Well, no problem. That neutralizes these. No, don't grab the big one. These go away then. What's left are 6. Well, we're not going to have 6 and nothing. It's going to neutralize even further to become 3 and 3. Okay, see how we did that? When we ground things, I showed you earlier how grounding oftentimes goes to neutral, but in this case we had an excessive amount of negative, so we simply have extra negative laying about. So now the problem would read, instead of having 12 and negative 18, let me renumber it. Instead of having 12 and 18, we have negative 3 and negative 3. All the other setup is the same. So let's do a calculation on that one real quick. Alright, let's do this. 8.99 to the 9th times 3, that's negative, to the negative 9th times 3, that's negative, to the negative 9th, hit my equals, divide by, and I remember from the old calculation, this squared is 0.09, so divided by 0.09 equals. And if you can read that, it's probably really small on the screen there. It says a whole mess of zeros and then 899. Well, 899. Check that out. Let's count how many zeros here real quick. 1, 2, 3, 4, 5, 6, 7 zeros. So it'd be bumped over 7 times. My calculations show 8.99 times 10 to the negative 7th would be our answer. Now check it out. 8.99 comes out nice and neat to there, doesn't it? Because look, 3 and 3, that's going to give you a 9 in the numerator, and 0.09, that's going to give you a 9 in the denominator. Those are going to cancel out if you want to look at it from that point of view. And you're just going to have some powers of 10 battling it out here, knocking that down. So there you go. That's the answer to number 2. Again, if you have questions, please pause the recording and see if one of your classmates understands and can answer your questions. Alright, let's move on to number 3 here. Alright, this problem is set up slightly different. 2 electrostatic, that just means 2 charged up things. Point charges mean they reside at a point, no big deal there, of this and that. 60 microcoulombs and 50 microcoulombs, so of 60 and 50. Repel each other, right, because they're both positive, so they're going to repel, with a force of 175 newtons. What is the distance between them? Well, look, we're solving a little bit of a different problem this time. Now we have Coulomb's constant again, times charge 1, times charge 2, divided by distance squared. But instead of solving for the force, we're solving for the distance. Now let's look at this from an algebra point of view. You guys can totally do this. This is not a big deal. So what we're going to have to do here is exercise our algebra skills a little bit. How about this? If this is being divided on this side, to counteract it, we must multiply it over to this side, correct? Yes, Mr. Wolf. All right. And then if this is being multiplied over on this side, to counteract it, we must divide it over. See how that happened? All right, let's do a calculation real quick. All right, here, let's do our calculation. 8.99 exponent to the 9th times 60 to the negative 6th times 50 to the negative 6th equals, divided by 175 equals, big long crazy thing, looks like it's repeating. And then we're not done though. We got d squared. To undo a d squared, we got to take a square root. And if you're using calculator like this, if you don't have a square root button, put it to the half power. So x to the y at the half power is just like square rooting, equals a distance of 0.39 meters, and that is a very familiar answer to me. I remember that from previous years. So 0.39 meters seems like a very reasonable number to me. But again, remember, if you didn't know about or you didn't remember about the microcoulombs, you might have, 3.9 times 10 to the something. Okay? Now, if you guys still have a lot of questions about this stuff tomorrow, I totally plan on being back tomorrow. I will gladly go over them in class. Again, if necessary. We'll have a sample problem again that is like this, and we'll help you understand it. Alright? Good luck with the next portion of your class.